Can I give you one? That's a nice product. In fact, all the calculus comes from that product.
There you go.
Thank you. Point it at me, would you?
It is.
Ah, let's put it over here so he's not looking at my back. All right, there we go. We're up and running now. All right, so we got a length and a width. Good enough? And derivation is all about how the area of this rectangle is going to change. Okay, and it really depends upon the function on the left, because every function changes differently. All right, but I'm just going to call that L prime. Some kind of change coming from a calculation here. Some kind of change coming from a calculation. What's the layering process? Those two layers. Okay, so what is this length? Oh, it's the same as this. What is this width? It's the same as that. So what is the change in the area, which I'll call dy? That's this. Okay, it sure looks like it's L prime W, length times, right? And this one is a dy, and that one looks like it's LW prime. Folks following the geometry here? And to get into this, really, you gotta throw some nasty calculations and then do maybe the sine function at 3 minus the sine at 2.9999 and divide by 0.00. You got to get into that minutia to really get a feel what's going on. But at this stage of the game, you don't need to do that. Okay. But you do need to talk about dy comes from what? L prime W and W prime L.
Good question.
Yeah,
What does dy stand for in this story?
change in area. This is why, right? When you know, I could have called it A and I could have said dA. dA fits better actually if I say here's your area. It doesn't matter. I'm trying to get to dy and dx because that's all you work with. Okay, but inherent in this process, and I guess I should show this. Do we know how x squared changes? X squared changes according to what? If y equals x squared, what is dy dx? 2x. Right? Because we've done some layering of changing. Haven't we done this? And this is x times x, yes? Isn't this simply a dx? Isn't this simply a dx times this x and that x? And can you see that we have our change in area, which I'll call dy. Isn't that equal to 2x dx? Okay, I'm hoping you're seeing that this is x times dx and that's the same x times dx. I'll make a big one there, right? And you're adding up two of them. This is called a differential equation. It's not a derivative. It's a derivative when we do the comparison, when we divide by dx. Okay, so what this is basically saying is if I want to change this area of this square, I start to do an x and an x, 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 an x and an x. This is integration. I'm adding up each of these layers. Each of those layers, that's integration, x and an x, x and an x. Okay, that's where we're headed in this course. Okay, now if I reconfigured this to be a rectangle, 1 x squared is that length. Then what is this layer of change? It's got to be 2x dx. It's the same function, just drawn differently. So its differential equation has to be the same. It's got to be the same, which means that if that's 1, that's 1. So where's this area coming from? 2x dx. Right? And we really got to play with some numbers to get into that. But if I played with numbers right now, you would be crying. So I'm not going to do that right now. We're just sticking with the geometry. Okay, so let's apply the product rule, x squared times x cubed. All right, let's just apply it. We know x squared times x cubed is x to the 5th, yes? And I think we know the derivative of x to the 5th now. At this stage, you should know how to take that, and it's 5x to the 4th. Okay, so let's do the product rule. The product rule says to do what? Take the derivative of the first. What's the derivative of x squared? 2x times the width. That's the width. This is L and W. So that's x cubed. And there's two parts, yes? And there's the other part, which is take the derivative of x cubed, which is 3x squared times what? The first one. That's the product rule. Now this is 2x to the fourth, and this is 3x to the fourth. I wonder what that adds up to. Seems to be the same thing. Okay. So quotient rule. Low D high minus high D low over low low is the jingle you want to memorize. And I should have written it on the, oh, it's written there on your tidbits, your cheat sheet. Okay, so what does that mean? Well, let's do one we know. Can we agree x to the fifth over x squared is x cubed? Oops, Jake. Jacob. We're there now. We'll get better. We'll get better at this. Do we know the derivative of x cubed? What is it? Okay, and so what's 3x squared if I put a 2 in there? 12. Okay, so would you draw the picture that of the discussion we just had in the last 30 seconds, what that 12 represents? Anybody know? Great question. What's this 3x squared represent?
Velocity.
It's a derivative, yes. And what do derivatives find you?
Velocity.
Velocity, or the rate at which something's changing at an instant. What instant did I give you? X equals 2. I gave you x equals 2, didn't I? I said put a 2 in here.
Oh, yeah.
Yeah, okay. Okay, so what's the drawing that goes with everything we're talking about right now? What should I draw? Anybody have any idea what I should draw right now? I'll tell you. I should draw that function, x cubed. And I should put a dot where? At x equals 2. And at x equals 2, what is x cubed? 8. That means grandma is 8 miles north of the Vermont-Massachusetts border. We just found her position. And what is she doing? Which way is she driving? North. At what speed? 12 miles an hour.
Hi,
Okay.
Mr. V.
Hi, how are
I got
you?
locked out of my room to time.
I'm so sorry. Okay. That was a very important discussion we just had. Right? Because you're actually trying to sort out what the hell you're doing. Okay. So when I put a 2 in, I know where grandma is. That's a position statement. This is basically her speed and direction. You know, I'm using the term velocity, right? That's about speed and direction. 12 is positive. That means she's heading where? North. And the number 12 tells you how fast she's driving. 12 miles an hour. We hope she's just getting on Route 91. Or pulling out of a rest area. I don't know. But if that's her constant speed, we're going to go get her. Okay, so that's what you're working with. So now let's apply the quotient rule, which should get us 3x squared. So low, what do you think low represents in this calculation? The denominator. So we're going to take the denominator, x squared, and we're going to multiply it times d high. What's d high? Derivative of the numerator. What's the derivative of x to the fifth? 5x to the 4, right? And then we're going to minus high. What's high? X to the 5. That's the numerator. D low. What's the derivative of low? 2x over low low. Low low is a multiplication. Can we just simply say square the denominator? And if we square the denominator, we get that, yes? I think we can work this algebraically. This is 5x to the 6 minus 2x to the 6 divided by x to the 4th. Everybody with me? That's 3x to the sixth divided by x to the fourth, which happens to be what? 3x squared. Right? Now, would I have used the quotient rule for this? Of course not. Because I would have simply said, oh, that's x to the third and taken a derivative. But when you have something like the sine of x over e to the x, you got to use it. Okay? And it can come from, I might as well show you what it can come from. I won't show you long. 1 over x times, what should I do? X to the third, maybe something like that. That's a product, yes? So I'd have to do the layering. And I'd have to take the rate of change of 1 over x. Anybody know what that is? No, that's the integral. Well, I guess you don't know. Is there another way you could have written x, 1 over x? Oh, yeah, if you're not sure, maybe there's another way to write it. Okay, and then that would become negative x to the minus 2 dx right there, times x cubed. And this would have been x to the negative 1 times 3x squared dx. That's the geometry of it. And if I fooled with that enough, it comes out to this saying. And I'm not going to take more time than that because it's a short period. And I want you working at the board with your names on the board. Okay, so that's where we're going now. Got to find the sheets. They're here. 10 problems. Let's see how many you can do. Work for the rest of the period. That's, you should know every value on it. Okay, and now you're going to take over with this young fella, and you're going to work right here. Okay, so we're going to do a worksheet. Jake's going to put the problems on the board, and he's going to explain them as he goes along. Okay, so team up. If you don't know how to do a problem, don't stand there. Go find a group that does know how to do it. Okay, lots of conversations. Please race it off and see if you can keep an idea of how the camera's working. All right. So you want to switch side. You're right-handed. Yeah, you want to be on this side. Yeah. Okay. Make sure that the camera can see that. Yeah. If you throw your names up, then you can use that one there. Want to use that one? Race it. Put those names up. Get those names up. I gotta learn names. Oh.
Probably not.
And then record your answers if you would, so we can look around and see if we're all getting the same answers.
You want to mention a 1 through 10, just some numbers so that we can write down. Find the approximate average change to the x for the interval negative.
And you can work with your calculator or without, your choice for the first problem. A lot of you are not familiar with these.
Move so you can see it. Yeah, and like do it and try and make it like backward.
Yeah, as long as you keep an eye here, I'm gonna move over so I can kind of see what's going.
Can I see? Yeah.
Yeah, as long as there's no flash
So,
over there.
We're
Sure.
finding
Just erase it really well. if you have
average
to.
rate of change for y equals x, e to the x for the intervals negative 0.7 to 1.1. No. I think it's 1/2.
Oh, yeah. But that's.
Yeah. And so now,
I got
No
it.
answer.
Charlie's gonna do some math.
Oh, he's doing it.
You should memorize.
So
Yeah, I just think from previous classes, you should know everything that's on it. Start looking at it every night. So all those really read something.
1.8
You should know what the square root of 3 is, square root of 2, so on and so forth.
minus 2.5.
it's 3 minus.
2.5.
And you might want to draw e to the x, so that, you know. So you're trying to, remember, you're hiding what you're doing now. So here's e to the x. This is the graph of e to the x.
Yeah.
You just found that negative 0.7 gave us roughly an altitude of 1/2, and 1.1 gave us an altitude of 3. And now you're going to draw 3 rectangles. And then try to figure out a calculation that would get you Oh, no, you're not doing rectangle.
I was
You're
just,
doing,
I was like,
okay, so this value here is the slope of the
Yeah.
secant. Okay, so you want to work with this either with the calculator or you want to do this as 2.5, which is 5/2 divided by 9/5, which is 5/9, so 25/18. Unless I made a careless error quickly.
no, it looks right.
Okay, that is the
So that's how
slope.
you want, so.
Yeah, you should work with stuff like that.
So if I wrote this on.
You know what you're doing. You told me you know what you're doing, but let's strengthen our just basic math skills.
Great, all right, so that's average rate of change.
Wait, this is right.
Yes.
So,
No, yes, what if 18? No, right? Yeah, and then do. Four. You did.
25.
Yeah. The same thing. You just moved the decimal.
Yeah, I know.
All right, anyways, now find the C value that satisfies the conclusion of the MBT for the interval. All right, so now we need to set e to the x equal to all right, so now we gotta solve. So ln. Sorry. I haven't done this in a minute. So the inverse of e is ln. So if we ln, we get the ln. We get ln x equals the ln of 25 over 18. I don't know if this is ln x though. Alright. So ln x equals to ln of 25 or 18. Okay, Mr. V. One sec. Mr. V, we give you some help.
Wait.
You might need a calculator for some of this.
Yeah.
Okay, sure.
So you're solving e to the x to be that, yes, and you're right. You use natural logarithms.
So then we get ln x equals
Yeah,
to ln
so
of
e
25.
to the x equals 25 over 18. You're looking for the value of an exponent. That's what logs are. All right, so x is equal to ln of 25 over 18. Can you approximate it without a calculator?
Yeah, that's what I was saying. All right, actually,
Well, I know what the ln of, I know e to the 0 is 1, yes?
sure.
And I know that e to the 1 is 2.71.
Yeah.
And I want e to the what equals 1.4-ish.
What do you get 1.4 from?
You gave it to me.
Oh, sure.
Then somebody else did it decimal.
Sure,
Okay,
so.
so what do you think your answer is between?
0.
0 and 1. So type in Google. If you have a Google, you know, all you gotta do on the space bar or the entrance bar, whatever the hell you call it, all you gotta do is that. That's gonna tell you what you put on top of E to get 1.4.
I just done, it's, oh, so I can just.
You're done. You're done with this problem. Go to the next one. But that's how you could get a feeling for the value, right? What was it? 0.3 something?
Can you write up there?
Okay, so that means this, just to make sure you know what you're looking at.
Of
That means
1.4.
there's the average rate of change at about 0.3, you're going up the same.
Right, use 3. Why don't you try this one? It's the same question. So you're doing, use 3 right-hand rectangles from e to the x. E to the x. And you want to find 0.7 negative
You know what even the 1 is.
0.7.
Okay, so either what?
1.1. You want to find 3 right-hand rectangles. All right. Just start from the right side. Right rectangles.
Squeeze.
all the way up, over.
There's your graph, there's your graph, so they can change.
Oh, no. You go out of line. No, you're fine. Over,
Where you going up?
down, up, over, down. Great. So now you gotta figure it out. Well, you gotta.
So this is
Personally,
that's correct.
I would take out, I would move over the decimal.
So you're trying to find, what do you put on top of it?
Yeah. So we're gonna take out the decimals because it makes it a little bit easier, I guess. We just gotta keep that in mind, I guess. Because what, it would be 0.4 over 3. That's weird.
This is what you started here.
No, these all divided by.
Yeah.
You're going up. Okay?
No.
Zero.
No. I mean, that could be right, but that's not.
But
Yeah, no, we did.
Remember, so Chad, you gotta make this make 30. So yeah.
You're trying to find the exponent. Yeah.
Oh, this is why we can't do that. This is negative 1. Not 7. You gotta add.
keep it sure it's keep it in.
It's 11. Oh, here's why. It's 11 minus 7. Alright. So it's 18 over. Okay, so we gotta add 18 to this. 18 over 3. Negative. Negative. Yeah, we'll do that later. And then we gotta add 18 over 3 to this, which is 15 over 3, right? It's easier to start off with that. So you go back to negative 7 here. We can go to negative 1 here.
It's like you multiply by
What I'm trying to look at now is now that we have these, right? Let me go back.
Where's the, you're giving.
Nobody ever says.
No, I want to, they got to be decimals.
If you can find something better. But nobody really.
No, but that was.
Okay.
Yeah. Yeah, there we go. Exactly. That's what
We can do the fourth question.
So we just took out the decimals to find it easier, but now we can go back to decimals. You want to do the rest?
So gonna say 18 over 3.
No.
No. 4 over 3.
No, so it's just 0.3. That's 0.3. All right. 0.6. 0.6.
So if I look at
And
how
then
this.
fill it in.
If I look at how this changes,
This one actually confusing.
if I keep layer.
Is it LN?
What? It's, yeah, E to the right hand. So you start off with, doesn't matter what you start off with. E to the -1. That's left.
But it says that's-
No. I was saying whether you start down there or over here.
You add and divide.
Yep. E to
I
the,
multiply and I add, that takes me this way, right? What's the inverse? Subtract and divide. So you start.
you got it. You see that? You got this is the left hand side of the rectangle.
Multiply and subtract.
No, I think it's different every time.
All right, so this is our answer.
3x squared came from what? What did it come from? It came from
Erase the whole.
2 plus 1 divided by 2.
Oh, it's 1.1.5 and negative
That's
one.
root of x cubed. 3x squared, that process takes me.
My bad.
Okay, so now we're gonna.
All right, fine. Now use 3 trapezoids, so I guess it's 2. So why don't you just try and do it?
So that's 3 halves, when you divide by 3 halves, same as multiplying by 2 thirds. Next is 3 halves. And now that is our position. We want to know where grandma was 1 hour from now, and where she was 4 hours from now. And that's gonna get the area from 1 to 4. We know how much your position has changed. Keeping track of your shit. So let's put a 4 in. Let's estimate first.
It's the same number.
Yeah.
This is 1, so that's a 2 times 3. That's 6 meters area. This is a little less, right? Underneath. Okay, so we should have an answer to that. 84. Okay, so you're okay with 16 thirds? Yeah, now the other table value is putting in 1, which is 2.
Yeah.
Remember, you got to divide that by 2. So 0.3.
Why? Right, why did
It's
it?
trapezoids. How I don't know.
I don't know how to do trapezoid.
Find out how to do that.
I don't know how to find it. He's always giving me why. No, but that's what. Yeah, but it's same.
So all we're doing is taking the grid, calling that this.
Yeah, good stuff.
We are going from A to B.
Just do this.
Right?
Oh, I didn't.
Is that right?
Yep.
How we doing?
Want that here? Just
Equation of line tangent. So all you're doing is writing an equation of line tangent. And do you need any help with this? So you did it on your calculator? Yeah. Let's do it without the calculator. Yeah, the same answer, because that is.
now find the exact area under the curve from square root of x for the intervals of 1 to 4. I don't think you.
I know the answer is 14 thirds.
That's the way to keep going.
Did you type this in properly? Okay, so now I want you to.
Go ahead, don't make a mistake.
We have a help?
It wants to know the area under the curve from 1 to 4. It's not using trap. It wants exact. Sorry, it wants to know this exact area.
The different fields most common.
The way you find the area is
Yeah.
integration.
Got a fresh board right here.
No, maybe. Oh, integral. Sorry. So this is the integral. You want to know the answer from 1 to 4 from the function the square root of x dx. So to start, take the derivative, the antiderivative of what's inside. So the way you do this is this turns to x to the 1/2. Take an antiderivative, so you add 1,
Ladies, come on over here.
and then you divide. So
Got a good mark?
you get x to the
She's gonna do that for you.
2 thirds
Okay?
to the 3 halves. 5, no. All right,
Why
so
wouldn't it just be like 1.5?
so you add,
How we doing,
then you
Max?
divide.
Help
So
you
so
with?
slower. I just do it quicker, but you're here, right?
Trapezoidal rule?
You're at 1/2.
Rectangles, 4?
You had
Three?
2
Three
halves.
rectangles, okay, so you got points.
Just
Then
yeah.
you're at x equals
And
3
the
over
right
2.
hand is 8.
Yeah.
Then from here, you divide, so you flip.
Now, this altitude is e to the
Right, great.
negative 0.1.
So now that we got
This
that,
altitude is
Then don't
e
you
to the
subtract
0.5.
and then don't.
And the last one is. e
No,
to the
this is an
1.1.
antiderivative. Antiderivative was the other way.
No, it's.
Different every time.
But now,
E to the
so we have
1.1 is about.
x to the 2
Come on,
over
calculate.
3.
Okay, but we want exact answers here. I
Now,
have the
you
height
plug
of
in
the
a number.
rectangle. What do I need to multiply
So
every
it's
height by?
big
The width, between 6, we're done.
minus bottom.
Now, if you want
So
to.
4,
If you want to
4,
estimate it, that's all you
square root
got.
of 2, 2 to the 3, 8. 8
is
times 2,
there's
16,
two
16 over
trapezoids, and you
3.
see that these are shared altitudes.
Follow or no?
So the ones in the middle, when there's
Okay,
two in the
I'm
middle.
literally
they're
just
shared,
solving it.
And the ones at
Look.
the ends only get one.
So now I'm solving the equation
Divided by two.
of
I
2
think you can go
over
around
3,
saying, yeah,
4
e to the negative point
to the 3 over 2. 4 square root of 2.
Yeah, you're there.
6,
You sound confident.
Cube square root.
And that's all you gotta write
Or-
for me.
4 times 2.
No.
Day three.
Where?
Day two.
Oh, 2.
Usually day four is batch.
Wait, it's called
Right?
square
We
root.
do
Yeah,
it again
square root.
tomorrow. You might
4 to
do
square root of
three.
2.
And then you put something in your pocket. You know,
4
you
to
keep
the
doing that
square
for everything
root.
we gotta learn.
1 or
All
4.
right, I don't read it till midterm.
4 to the square root of 2.
Square root of
All right,
2.
makes sense.
4 to the.
Do I
What's
need
the square root of
help?
4?
Anybody over here?
2.
Great. 2 to the 3.
I just said 2.
Yeah, great.
Do you do the actual
2 to the 3.
Okay. So
8. 8 times 2. 16 divided by 3.
So what you do here is.
16 over 3. Sorry, I didn't word that right. Then we take 1. 1 square root of 1, 1. 1 to the 3, 1. 1 times 2 thirds.
That's
That's the area under the square. Hopefully. You look pissed off. Wow, I'm trying to help. You just don't understand it?
No, I
Right?
Why are you pissed?
Except from 28.
Um,
the orientation. If you look at
Anyone else?
can you read that? You're not supposed to. Isn't that how you do?
let me make sure it's right.
And we're only looking at that.
Wait, Charlie, what problem are you gonna?
We're right.
Maybe it was 14. Oh.
We're right.
There, makes that.
Okay, it's closer to 5. Is it believable that that area might be close to 5? Yeah. Now, if this was the virus, right, then we'd say 5%.
Do you know equation line tangent? You want to know the equation of the line? Equation of the line tangent to y equals square root of x.
I think he's right.
That x equals 9. This is also very easy. You'll get this quick. You know it? Okay. Nope. Sure. All right.
Questions?
Yeah, we're not certain.
So
Okay, and I just want, okay, I'll do that.
now,
I just want to.
equation line tangent. First thing first, it's
When you.
the first thing you gotta remember is this.
Yeah. That's in position right. So you found out.
And you gotta fill it in. Derivative x minus 9 plus square root of 9. Now you take the derivative and plug it in. All right.
Derivative of that.
Yes.
What's your question?
This is it's a memorization.
Okay.
But the way to actually do it though is what you should do just for now is to take x to the 1/2, multiply, then subtract 1/2 x, and then subtract 1/2. So you're at 1/2 x. Another way to write 1/2 x
Yeah.
is to put x on the bottom. 1/2.
You guys can.
For whoa.
Oh, yeah.
Number 5?
Yeah, that's an approximation. But I kind of like to get.
Where do you guys get e to the x? Number 5.
That's a really good question.
Yeah, just like the.
No, number 5 is a different question.
Probably one.
No. Oh, you just gotta plug it in.
Acceleration, quadruple prime, which is 2.
You literally,
All different ways.
Let me just clarify something real quick with him. But my answer would be, if you plug in 9, carry to 9, 3, my answer would be 1, 6. Got it?
You just got.
9.
He's lucky, right?
I plugged in the 9 to the derivative of the square root of x. But I just gotta, I want him to show how you get this, because
Are we doing the equation line?
Leg nuts. Yes.
And then plug in 9.1.
I've seen this one.
What's this sudden surge in intelligence?
And you're gonna get an answer that's pretty close to that.
Yeah, that's a blank guess.
That's how accurate it is, because when you put a tangent, right, how far, what kind of separation do you really get in the white from there? Not much. So it's a quick way to get some values on the field. Now, yeah, they can write it out here.
It's there.
So let me explain. All right, ready? I'm messing up a tiny bit. The answer is right, but I explained how to get this wrong. So you have, I'm gonna try to write it super neat. So I'm going over the derivative of the square root of x. So you start here, right? Turns into this. I'm trying to straight down the line. So now it's easy to take a derivative. Do you understand this?
Yeah.
The correlation? Great. So now you take the derivative, multiply, and then subtract 1. So and 1 in this case would be 2 over 2. Right? So now you have 1/2 x to the negative 1/2. Now, negative 1/2 here, we can now rewrite that. If it's to a negative exponent, right, we can put it on the bottom. So now we have 1 over 2 x. Now it's going to be a positive 1/2 because we moved it to the bottom.
Ready to give you a great explanation?
1/2. You with me? Because you know how if you have x to the negative 5, very important, 1 over x to the 5. We have x to the negative 1/2. Now we have 1 over x to the negative to the 1/2. So now that we have this, so you have this turns into this.
Equation of the line tangent. You want me to do a tangent line for you?
Because x to the 1/2 is square root of x.
Okay, so I'm gonna do equation of the line tangent.
So I'm doing that right now if they
All
want.
right, you keep doing it.
And then so when you have this, you plug
Can I put a 3 in and get a 9?
that. Square root of 9, 3 times 2,
Oh, no.
6, 1 over 6. That's the
I
equation
don't
of
know,
the
you tell me,
tangent.
I know I'm looking at
That
x
is
squared,
when-
right? I'm trying to find out the rate at which I'm changing.
Great. I'm gonna write that. right here.
I guess I gotta have some kind of tool to use.
Do you understand everything? Is there anything you want me to go over?
To find instantaneous rate.
Like, what do you like?
Well, there's a technique in calculus that we can work on that finds instantaneous rate of change. And I'm trying to see if your brain is connected.
Use the line tangent to approximate 9.1.
Well, we're looking for instantaneous rate. You actually used it in that first and second.
I don't remember this, but
Where you set the average rate equal to the what? Oh, the derivative. What's the derivative squared? 2x. Oh, but if you put a 3 in, then you're going up at 6 to 1. So what's the equation on that tangent? 6 times x minus 3 plus 9. Now you're doing it more complicated. Yeah. Make sure you can see. Yeah. You want me to do that for you clearly?
well, no, I remember it's like it's
X minus 9,
yeah. I'm getting
right? With the square.
no, but I was gonna ask for help.
Am I here or not?
Yes.
All right, what's the square root of 9? So we know that, right? We know that on the square root, we're at 3/9. We want to know at what rate are we changing? Okay, and that means you got to take the derivative of the square root of x, which I'm asking you to memorize as 1/2 root x. Can you put a 3 in there now? And what do you get if you put a 3 in there now? So y prime of 3 equals 1/, I'm sorry,
Yeah.
9 gets you 3, big time apology. Okay, so 9 gets you 3, big error on my part. If you put a 9 in here right now, what do you get for slope? 1/6. So this is going up at 1/6. Can we write the tangent line? Yeah, 1/6, right? That's this line. And now I want to use that line to approximate what? 9.1. And what line am I using? 1/6, x minus 9 plus 3. Can you plug that in now? And if you do plug 9.1 in, don't you get a 10th? And a 10th times the 6 is the 60th. Don't you get 3 and 1/60? Well, that's your answer.
Also,
If you check it with square root of 9.1, you're off about 1,000th of a decimal point. Yes, well, no, I was doing a square root just to show.
Oh, okay. I was confused. Okay.
how to do it. So now you're doing it with the square root of x, yes? Okay, so let's move it together so you can move along. Square root of x, yes?
Great.
Okay, we have a 9 versus a 3. Okay, so instead of 3 here, we're going to go here. Yes?
What?
I need to know the instantaneous rate of change there. What is it? Derivative. Have you memorized the derivative of the square root of x? Easier form? It's 1/2 root of x. Better to memorize.
All right, why don't you?
Okay, so now I put in a 9. I guess I'm going.
All right, ready?
Oh, it's a deep part.
Right, well, that's a new tool for evaluation.
More complicated.
Because that's where we're looking. Okay, so there's my,
Yeah. You want to try
there's
it?
my tangent line, and I want to approximate this using the tangent
That's what
line.
you did.
So what do I plug in? And if I put 9.1 in here, that's a 10th. 10th times that gives me 3 and 1/6. And if you put that as a decimal, and you do that as a decimal, it's about 1,000th point error. The error ratio is about that. That's pretty close. But this is a little bit bigger because the tangent line really is above it, right?
Yeah.
But when you get close,
You know.
you can use the line. Ah. Do I need to give any help here?
What they have.
Okay, I want you to memorize this. As 1/2 root x.
The whole thing is pi, right? Or is
So
it?
1/2
Half is pi.
That's easier to work. Next, we agree that
Whatever.
No,
we agree that a 9 gets a 3.
You can plug in X for them. Right, so 2x.
The slope
Six.
Oh.
Now.
And then you create this.
Well, it's not 6. I guess it's
This is what it-
That's what he
This
did.
is the defined slope, number
Ready?
nine.
So it's 2 times 3.
Now I have a new function.
No,
I
it's
have a new
not.
function.
Yeah.
I'm pretty sure. Aren't they kind of overlapping? So as long as I'm using something here, I don't want
Yeah,
to.
I'll keep the memorization.
Eventually.
Um,
It's a good approximation for finding this.
All right, first thing first, Charlie.
And then you plug in X. plug in Y,
Charlie,
What am I putting
And then you
in?
plug in.
This is
that
right?
change, you know, 2 times
I don't know.
2x, et cetera.
Yeah.
Oh,
And
you
then
said-
that's it.
Yeah,
And you do that
that's
for
right.
whatever.
All right, ready?
First
First thing first.
Remember this, the derivative of
Parentheses.
X.
Oh.
X
minus
minus
2.
2. Do you see a connection between everything smaller than
Yeah,
this?
but this one's.
Yeah.
Is
Nice.
the given goes with X in the parentheses.
Because I don't know.
All right,
But I can do this.
now you should apply this. What do you think goes here?
And they're going up the same way, right?
2 times 3.
No, not looking at this.
1, 6.
Conceptually,
And that's-
what
that is-
type of number? Like,
Yeah.
attaboy. Good stuff. Now, sine. What's the derivative of sine? Okay, derivative of sine, cosine, derivative of cosine, negative sine, derivative of negative sine, negative cosine. Derivative of sine, negative cosine. Derivative of sine is cosine. What's cosine?
Negative.
Now,
So in this case.
derivative or not derivative. Now, what's sine of 2 pi over 3?
Yeah, here, 9.1 we got from this book. He just took the root of 9. So we're using square root, right? So it's the same equation. So if we said. Yeah, but if you said 9.1 squared.
Oh, yeah.
That would be because
Oh, wait, no.
X squared, right?
And to make sense, it didn't. When you start using the unit circles like numbers, it can get a little more confusing. Use the derivative to find the minimum. All right. This one he hasn't taught us yet, but look. For what? No, we're not looking at that. Alright, ready? So explaining that derivatives, the way you write derivatives, you know, you keep using prime. Derivative of this is y prime. You're right, 4x minus 12 plus. That's it. And now it wants a minimum because the derivative of 7 is nothing. Not a good. It's a constant. But I'm trying to figure out a minimum. I mean, I guess you solve for x maybe. 4x minus 12, 0. 4x equals 12. But no, that's not right. This is your this if I were to graph this out, 3 is your velocity. It's your average rate of change. But so look, this is something that we're trying to get at is position, velocity, acceleration.
Just why there two.
Double prime, triple prime, quadruple prime. Goes regular, y prime, double prime. The more of these, but let's see what they got. Yo, have you done 9?
9? No. That was the first one.
I think it's just 4.
Right there. Yes. Root, right? No, I just copied this. Too loud, bro. Oh, I remember. I never needed. I think I remember this too. It was 2 pi over 3.
So once I found her,
Right, plug into the original.
and that's it.
That's the vertex.
Oh, all right. So I was actually right.
So can we agree, watch. Can we agree that this is a parabola?
Yes.
Tangent means I'm drawing that, yes?
Yeah.
What's the slope?
We said 3.
What's the slope of this tangent?
0.
0.
Yeah.
What makes that 0?
3.
3.
Yeah.
So we had it.
Then we
Plug it in.
3 to the position.
Sure, that's negative 18 plus 7, which is negative 11.
So I was, sorry, the only thing
And
I
that's the
was,
same thing as minus b over 2a.
I was just.
Oh, Jesus, what happened here? Oh, okay. Get some paper and start scrubbing. What did I do? I opened the wrong end. Come on, help me out here. Get some paper. Go to the, go get, go to the toilet. Get some, throw some, yes, those things are wet. Good, go, good. I can't bend down. I opened the wrong end. I dropped off. It's gonna, throw it. Give it, come on. Come on, it's
Don't
coming
rub
out.
it in more, don't rub it.
Yes, yes, I had this happen once before. It'll come out. Yes, if you just keep scrubbing, it'll come out.
Mr. V.
Yeah,
So
scrub.
I was.
Save me. Save me.
I was
You
used.
it's coming out. Save me. Come on, put some elbow in there. Come on, hard. Come on, Charlie. Come on, dig deep, Charlie. Come on. No. I can't believe I did that.
Mr. V.
What?
So I was used to having like two, like to find a minimum and a maximum. Isn't there like usually two options you have to find out?
We're gonna develop it more.
Okay, that's why I was looking.
We're gonna develop.
And does it come from the acceleration or velocity?
Comes from the graph. Looking when it's positive, when it's negative.
Okay.
New ones.
Kind of makes it look nice.
Huh?
Gives it some flavor.
We're getting all that. Oh, doesn't it, huh? New ones, new ones.
Moonshot.
We would have gotten it up quicker if I'd seen it sooner.
98%.
I'd seen it sooner. You ready? What the heck, you know, they're ripping the building up. Who cares?
Yeah, exactly.
Jesus, what are we? Good enough. The building's coming down. It doesn't matter.
Wait, are we gonna be in
Where's-
Gilder at the end of
Yeah, I
the
know.
semester?
All right.
Good enough.
All right, Charlie, let's get it.
Keep going. How we doing? We almost done?
Last problem.
The trash.
All right, let's have a seat for a second. I want to show something to everybody, try to pull some things together.
The thing's still going, so make sure it's in the right place.
Thank you. All right, some of you have already done this, but I want to do it and make sure everybody sees it today. There you go. All right, so. All right. So if you have a graph like this, right? We call these things local maxes and local mins, yes? And if I draw a tangent, do we know the value of the slope of that tangent? 0. Okay, so there's a real easy way to find maximums and minimums. Proving which is which is another matter. Maybe we'll get to that right now too. Okay, but how do you find instantaneous rate of change? What do you work with? Right, I'm hearing that more now than I did yesterday. Okay, so the question was, how do we graph y equals 2x squared minus 12x plus 7? I think that's the one you were working with. If not, it's close enough. And in, your pre-cal days, you looked at minus b over 2a. You knew that was the x value. Y minus b over 2a, you may not have gotten to that. Too bad. Would have been nice if somebody explained that. Okay, but you work with that and put it in graphing form, right? But in calculus, we can do it too, because we think we know that that has this shape, yes? So therefore, we set its derivative to 0. What is the derivative of that? Yes, the derivative y prime is 4x minus 12, and we set it to 0. And all of a sudden, we know the important x value, yes? And it's 3. And if I want to find the y value, what do? Plug it back into the original function, and you'll get the classic 18 minus 36, the classic 2-to-1 opposite ratio, right? Always 2-to-1 opposite. And there's negative 18 plus 7, negative 11. Okay, and it's just a different way of finding the vertex using calculus. Now, I want to extend this. I want to extend this to you. Watching here. I can actually write this function using an integral. Using this. 4x minus 12, because that's little f, yes? So we are going to look at, from 3 to 5, I just want to look at 4x minus 12 dx. Do I have time or is the class over?
You have like 3 minutes.
That's all I need. Okay, I am going to look at a graph now. Here's 3, here's 4x minus 12. Everybody recognize the line?
Yeah.
Okay, and this is the critical moment. What are the y values of that derivative before 3? How would you group them? Like you put forks and spoons in a drawer. They're all negative. Every rate is negative here. Right? What does that tell you about what way grandma's going? Yes, south. Decreasing. And then they're all positive, which means she did what? She turned around and headed north. In other words, the y values are increasing. That's a huge thing to make sure you understand. We'll keep talking about it every day. Now, what happens to these y values? They're getting bigger too, yes? That means her speed is going up. Does it look like the tangents here are getting steeper? Well, that's the reflection of her speed going up. Okay, and the real thing I want to look at is the table values for 2x squared, oh Christ, 2x squared minus 12x plus 7. We put a 3 in, we know we're at negative 11, we already did it. We put a 5 in, 50 minus 60 minus 10 plus 7 is negative 3. How much did I change from negative 11 to 3? 8 units of change, yes? So grandma has changed her position by 8 miles. Let's look at the area under the curve from 3 to 5. If I put 5 into this, 20 minus 12, that's a height of 8. 3 to 5 is 2. What is this area? Oh, 16 divided by 2, which is what? 8 is finding that. That's 8 units of area, and the area represents the distance that she has changed, or the positional change. Okay, trying to put it all together so we can start working. Your homework tonight is redo this sheet and then turn it in tomorrow.
Is there a math class tonight?
I don't know. I know Monday, Tuesday. It's either tonight or Thursday, or maybe it's both. I don't know if the department is taking turns.
Do you know which night you're on?
I'm on Tuesday night. We had about 30 people come last night. It's a lot. I encourage everybody to come and do what we're doing here. Do more practice. I don't know. I don't know. It's either tonight or tomorrow night with Mace. She does one more night. I don't know if the department. They'll do student announcements. Yeah, fine, I'm sure. I don't know. They're right here. They're right there. Yeah. Yeah, I think I saw one somewhere. Okay, all right. Yeah.
Thank you, Mr. Green.
Yeah, I want to see you, I want to see you work through all of them. If you need to get together with somebody for the last one or two, do it. But reconnect with it, don't forget what you did in class, and then try to retrieve that memory. Okay? Yeah, you can make you Mr. V. Really lots? Well, I want you to come. That's fine. It happens a lot. A lot of times people come in tears, and sometimes they end up meeting with us students. So I really don't know. So you stuck it out how you do it. But if you're not feeling comfortable and you want to change, no problem. Mhm. Right. So you feel like your foundational skills are going to cause you. No problem. Mhm. Mhm. That's fine. I mean, I'm overloading so that we can eventually slow the pace down and figure out what the hell's going on. So it's an intentional overload. I was in a Spanish class in Mexico. The teacher was doing the same thing. I didn't realize it. And after day 3, I said, I'm out of here. Right. And then the teacher came in and said, oh, let's stop now and just keep going over the things we've done. And I know how my students, you're experiencing that right now. Right, so that's fine, your choice. If you want to think about it a little longer and talk to some previous students as to how the process works, welcome to do that. Otherwise, you know, you got another course that you feel like you benefit from. Everybody should take a statistics class before they graduate from here because you're going to use it in college. So if you can get in one of those, it's more useful than this.
Yeah, I was thinking, like,
Yep.
people said that like calc is not typically.
Oh, it's very different. Calc AB and what we're doing right now, we're still on the same page, doing the same work. It'll diverge eventually, but right now it's not. Right now, we're basically just covering the same concepts. All right,
It's how we, which is
it's gonna be, I'm gonna expect a whole lot more. I'm gonna give more detailed calculations. Yeah. Talk to your advisor.
yeah, I talked to him yesterday.
Who's your advisor?
Tim.
Tim Reliant?
Yeah.
Okay, yeah, he's been around that long, so I don't know what he thinks about this process or.
He checked at the time of the schedule saying that I switched and all the location.
Yeah, I understand the anxiety and throwing so much boom, right? But the only way that you're ever gonna get it in a working knowledge is to slow it chip away at it. So that's why I'm doing this. Right, the last time I did a test for the fall, the college board, you familiar with the 1 to 5 grading? 5 college credit and top AA minus. Okay, so I had 16 kids. The other 2 classes, there were 32. Of the 32, decided out of those 32 students, 3 decided they take the test. And 2 got 2s and 1 got a 3. My class took it, 8 got 5s, 2 got 4s, 2 got 3s. So I had 1/3 of the students, but I had 4 times the amount of kids take the exam. And we more than doubled their score. So the average was 4.5 out of this process versus 2.67. I'm not going to change because I know what it takes to actually understand what's going on. A lot of repetition. I can't get the repetition without killing people at the first week or 2. Just can't do it. So I kill it. I know what I'm doing, and it's painful, and to be feeling lost in what's going on. And the issue really is if you can pick up one thing a day, at the end, you're probably pretty solid.
I just want to know when we would be kind of like, I know you said you would slow down,
Mhm.
but by how much, like it's right now, really.
That's going on for a while.
Yeah.
Because everything branches off the 2 major concepts: product rule and quotient rule, just memorization and just technique. The only way you can learn it, just to do it every day. I put it out there immediately. We'll do it again tomorrow. We'll do it again the next day. We'll do it again the next day. 4 days from now, no one should have a problem with product rule quotient. They just do it once. But we're doing that with all kinds of things. So that's the process. So talk to Tim, sit with it, decide what you want to do, and be comfortable. Be comfortable. Yeah. I don't grade till midterm. I mean, what you're doing right now. I mean, I had a kid, I reviewed algebra 2, and he was in my pre-cal. I did all the algebra 1, algebra 2 review for seven straight days. Just write the equation alone. Factor x squared minus 25. I had 50 questions. My score was 8. 8 median. 8, right? Of stuff that was algebra 1 and algebra 2 that was supposed to be learned. This kid got 4. 2 days later, he got 44. I've never seen that before, right? In other words, he obviously had a bad experience probably, and then connected with it. And then he went to AB, he's going to multi next term, linear algebra the next. And I was ready to move him down based on what I saw him come in with. But the kid had some ability, just never was allowed to take on. So I never know how somebody's going to do it, right? But I do understand the tension, the anxiety, all that comes with the initial road. This is so different. So different. Yeah, but a teacher will tell you they didn't understand what they're doing until they taught it the second time. So how the heck do we expect students to understand? They don't do it. Can't do it. Yeah.
I have some problem with this one. So I tried this in.
I'll do it for you. I'm not going anywhere right now. Just raise the board for you. Right, raise the board, I'll do it for you.
Do you know what?
Greg Hefner? He teaches here every day right after this, but it's Wednesday. So I got no idea.
I saw class.
Did you email him?
Yeah.
His wife might be, married. Yeah, she's the department head. She's in the building, she's know where he is.
Thanks, Mr.
Sorry,
B.
I can't help you.
It's all right. I was waiting on this phone. Thank you.
How about we use that board over there? All right, what are we looking at? What number?
Oh, I said.
All right. Good. Why are we what? You'd have to look up the derivatives.
Cos of X.
All right, so you'd have to look up the derivative of cosine X.
Yeah.
And you'd have to look up the derivative of that.
Yeah.
Okay, so low,
I'm ready to look it up.
there's low,
Yeah.
D high is minus sin X. Show that graph later. That's the derivative of that. Low D high minus high, D low, 1 and 2, times 2 to the X. Over low, low, and you're done.
Must be sliding.
Okay, well, that's what it is. So it's low, derivative of high, minus high,
For some reason,
derivative of low.
I got this. Over 180.
Where's 180 coming from?
Yeah, just shut this.
Yeah, we don't do anything more than this. But there are no values on this one. You know, I don't even know what this looks like. I mean, this is 2 to the X. Cosine X is this, right? And I'm dividing these things. I'm dividing that altitude into that altitude, this altitude into that altitude. I think it's complicated.
Yeah,
Yeah. I have to look at it. You know, I could come up with a decent picture. Take a lot of work.
So we just have this like, I got this one.
Well, did you follow that?
Yeah.
Then want to give you one tomorrow? See if you get it right.
I also have a question with you. Yeah, with the tangent line equation.
Alright. So do you understand how to do a tangent? Probably not. All right, let me do an easy tangent. And we'll do that one, right? All right, so let's do it here. It's more space. All right, so here's X squared. With me?
Yep.
3 gets you 9. So 3 hours from now, grandma's 9 miles north of 4. That's a position state. How do I find out the rate at which she's changing?
I do.
Right, the root of X squared is 2X, yes?
Yeah.
If I drop in a 3, she's going up at 6 to 1.
Yes.
So if I want to write the equation of this line, I know she's going up 6 to 1, and I want to highlight the number 3, 9. That's the equation. That's the process.
How do we get X?
How do we get X? I gave it to you. I just gave it to you.
Oh.
So the position 3 hours from now, you put a 3 in, it makes it 0.
Yeah.
0 times anything is 0. She's at 9.
Oh.
That highlights this point, 3, 9.
So that's all what we need.
If I'm writing the equation of the tangent line to y equals x squared, at x equals 3, that's what you're trying to do. So now you're doing it with a more complicated function. So what function did I get?
Y cosine of X at X equals
3 pi over 4. So 3 pi over 4 means pi is the top half of the circle.
Yep.
I'm going to divide it up into 4 parts. Right? 1, 2, 3, 4. There's the third. There's my 45-degree angle. There's my root 2 over 2. And there's my 3 pi over 4 radius distances. 3 times 3.14 divided by 4.7 times 3. It's about 2 point something. So I'm going about 2 radius lengths. 1, 2 to get there. Yeah, that's what a radian measurement is. I know a lot of students don't know that. So I'm trying to give you this because I know we're weak here.
Yeah.
All right, and so that's minus root 2 over 2. That's the cosine value.
Yes.
That's the sine value. And this is the distance on the circumference of the circle I travel to get that out. So I'm going to write x minus 3 pi over 4. That's the input. That's the angle. This is the ratio you get. And this is the slope, the cosine. Because the cosine is the derivative of sine x. Phi prime is the cosine function. Now, that is negative 0.87. The sine function is this.
Yeah.
3 pi over 4 is about here. Does it look like I might be going at negative 0.87 down if I drew it well?
Yeah.
And that's the location, 3 up high. That's what you're trying to find out.
So let me go through the procedure again. So when we find the derivative
Find the derivative,
of the equation,
plug in the x
value
value.
the X value,
That tells you the slope of that answer,
and then
which
so
is this.
find the slope and then find the y.
Find the y value that goes with the original function, or 3 pi over 4.
That's it.
Sure, so I now know 3 pi over 4 is about, we said 2 points, so a little more than 2 hours from now.
Yeah.
Grandma is 0.87 above the border of Vermont, Massachusetts.
So just.
And she's heading south at that speed.
Okay.
That's what I know, if I use the grandma now.
Yeah, okay. Just making sure, finding the derivative is the rate of change.
Yeah, and I'm gonna print one out later today. I gotta go someplace.
Okay.
But I'm gonna print one out later today, because I thought I put it in this packet. I want you to have all those derivative formulas.
Oh, I think we do, I think I got it.
Is it in there?
Yeah.
I thought it was in there. Yeah, no, well, you have that now, right?
Yeah.
Yeah, but I didn't put derivatives on.
Oh, right.
No, that's just your pre-cal algebra too.
Okay, sure.
So I'm gonna go to the internet.
For question 6, what do we do with it? Do we just,
Well, you do the mechanics.
oh,
So if you go from velocity to acceleration, what do you really take? What is the technique that we're using in calculus?
velocity.
Yeah, what is the relationship between velocity and acceleration? What does acceleration do to velocity?
It's like a change.
It changes it. So
Yeah.
we're looking at how velocity changes.
Yeah.
And acceleration tells us that.
Yeah.
So there's only two things you do in math and calculus. You either take an integral or a derivative.
Oh, okay.
And which is acceleration telling you? Is it telling you how far somebody's gone or how something is changing?
How something.
Yeah, it's changing velocity.
Yeah.
So you're taking the derivative. When you're going from velocity to acceleration, you're taking the derivative. If you want to go to position, what are you doing? You're integrating.
Okay.
And if you integrate 5x squared dx,
Mhm.
do you remember the technique for integrating? It's 5x to the 3 over 3 plus c.
This is the.
Yeah, you're just adding 1 and dividing.
Oh,
And
okay.
that takes you to the position statement. Now take this derivative. What's the derivative of 5x cubed divided by 3? You multiply by 3, what happens to the 3's? If I multiply by 3, what happens to the 3's?
Cancel out.
They cancel, and if I drop down by 1, what do you get?
You get.
5x squared,
5x.
the derivative.
Okay,
So I'm just having you mechanically practice that so you get good at it.
okay,
And of course, it's early, and I have the rule of 4.
yeah.
So if you do that 4 days in a row, I think you'll own it.
Yeah.
We can do that with most any problem.
Sure.
That's why I can jam them down your throat right now.
So,
Yeah.
this is called finding the derivative or integral.
Yeah, you're from left to right, you're
Alright.
taking derivatives.
Okay.
From right to left, you're taking integrals.
Oh, that's the difference.
So let's integrate this.
Okay.
Let's integrate 10x dx. What do I do? This is a 1. What do I do?
Cool. From,
Integration is the inverse of derivation.
could you please try to remind me?
Well, in a derivative, the
Yeah.
exponents go down 1.
Yeah.
What's the inverse of that?
Oh, so it goes up?
So it adds 1, and then that's a new exponent. You divide by it.
Oh.
What do you get? What
uh,
is 10x squared divided by 2?
That's 5x squared over 2. Oh, where's the 2 go?
Just above the x.
Oh,
It's 5x squared.
yeah, 5x.
Didn't that mechanics bring us to here?
Oh, yes.
So integration moves you to the left,
Mhm.
derivation moves you to the right.
Oh, okay. Okay.
Mhm. And what you're basically doing is 5x squared comes from integrating 10x. So here's the area. There's the area under 10x, right? I'm moving to the right, that's positive width,
Yeah.
but my altitudes are negative.
Yeah.
That means I'm accumulating negative amounts.
Mhm.
What does 5x squared? Doesn't it go down?
No.
This graph is a quadratic, yes?
Yeah, it goes.
Right, and it goes down from left to right.
Oh, and then it goes.
And then the values are positive, goes up.
Oh.
Faster and faster and faster because these are bigger and bigger rates.
Oh,
Okay, so we're going to try to look at it holistically as to how this affects that,
oh,
so that we get a sense of the whole picture.
okay.
That's what we're after.
Sure.
And it's day 3. Have you learned anything in the first 3 days?
Yes. like
How
a lot
much?
of things.
A lot of things. Oh, so if you're accumulating a lot of knowledge in 3 days and we keep doing that,
What would you keep with
then
you?
I would think you're accumulating a good understanding.
Oh.
Right? Or we can go back to just, everybody else is working on limits right now.
Oh, yeah.
Not talking about any of these.
I actually really like the way all we learned this.
I hope so. I hope so.
I think usually people just like go through one concept at a time and then. I just-
Well, you never get to see the picture, how they relate.
Yeah, exactly.
Everything is
I think I
relating
like
here.
this. Yeah.
Then as soon as we get the mechanics down, we can start looking at more of those relationships. We're going to try to look at it from numerical perspectives too. Right now, we've been heavy on the geometric. We're going to get heavier on the graphical. What we just did was a graphical, perspective of the same major concept.
I'm getting it.
Yeah, you're doing well.
Thank you.
Okay, and you'd stop anytime like that as long as the next class isn't coming in. So at least, and then Tuesday nights, right?
Yeah.
Yeah. Tuesday, people that come on say what?
And Thursday?
I don't do it. I just do Tuesday, but there is help Monday, and it's either tonight or tomorrow night.
Okay,
And on the next class, which tomorrow morning, can you remind me to have everybody at the end of the day erase?
yeah, sure.
It's not, I don't mind doing it. It's just, I think people should learn.
Okay.
Now, you gotta remind me of your name again.
Jimmy.
Yeah, Jimmy Long?
Yeah, Jimmy. Long.
I got you.
Okay.
That's good.
See you, Mr. B.
Yeah, thanks for stopping. Stop.